experienced engineer with 5 years work on MLOps platforms. He's obsessed with engineering simplicity and performance in the system he builds, and he's helped build the MLOps platforms at Overstock and before he joined Clicklease in 2024.
So I'm going to switch it up. I'm actually going to talk about how we used Hopsworks as a feature store who's, putting together this beautiful conference. It's been amazing to hear some of the talks on some of these large scalable infrastructures, and some of the problems that you're solving. This is going to be a little bit more humble to some of the problems we're solving in some ways. So agenda, explain the machine learning use case, describe the issues of previous processes and what was wrong with them, and explain how we used Hopsworks to address the issues. So I'm currently at a company called Clicklease. I came here about July of 2024, so a little over a year. And I came here I was at Bed Bath & Beyond before, and then I was at Overstock before that. So I was in e-commerce for 8 or 9 years before I came here. And this is a much smaller company that what they do is they create micro leases for small business owners. So they don't go above a certain amount of capital. I think the max is about $30,000, but you can get a lease for like $10,000. So think like taco cart, gym equipment, kitchen equipment, stuff like that. And there's not a lot of players in this space. They don't really want to handle it. So the flow kind of looks like this. You get a small business owner, they go into a store. Let's say they go in to buy a trailer and they're a small business owner and they don't have the money to buy the equipment. So there's a barcode there that they can scan with their phone and they can apply to lease it. So what my company does is we take that application, we bring it to our service. We call all kinds of third party data providers. There's been a bunch of fintech people on here, so all the typical stuff, credit reports, fraud, bank verification, all that stuff. We pull all that in and we run it through these risk processes, and then we make a decision to approve or deny. So we buy the equipment up front. So if it's a $20,000 trailer, our company buys that equipment and then we lease it to the small business owner with the option to buy out later. But we don't have a lot of, coming from e-commerce, we don't have a whole lot of traffic. We have a lot more humble amount of traffic, right? But we probably have margins about as high as the last company I was at. So our profit levels are just as high with a lot less traffic. So the online decisioning that we do is we predict the probability of default. We do fraud, pricing of the leases. We do service people with poor credit or no credit. Obviously, when they do that, they charge a little bit more, right? For those of you in Europe, I am in the United States of America. I apologize. And, rules and regulations, right? There are different rules and regulations for different states, different situations, and we have to log that. We have to account for that. And then there's a high cost for mistakes. So I say that because at my last company, we mostly worked on like sponsored products or recommendation systems or search, any of those types of things. And if we we were trying to optimize stuff like, NDCG, and if you show a red couch with a bunch of blue couches, your product managers are going to yell at you and they're going to be upset and people are going to say, this is a bad experience, but it's not going to cost you a lot of money. The mistakes here, if we approve a fraud use case, since we're buying the equipment, if we approve fraud or someone that's going to default, we can potentially lose all that money. So it could be 10 yields for one bad yield. So there's a lot of attention to detail on how we make these decisions, right? When I showed up at the company, our architecture, the rules engine that we kind of had was built on a lot of stored procedures in Postgres. Any of my developers out there, you know the pain of stored procedures if you've worked with them before. I won't get into that. But what we basically do, right? They call us, we call all these third parties. Um, we have to parse that third party logic into usable features or usable like logic rules. A lot of this was logic rules and it was stored procedures operating if credit score this, then do this, then do that, then do that. And we started to replace with models. And when I got there, they had replaced a lot of this with a few models. But those models were all in fast API applications, and they were calling this store procedures from the service, right, at request time. And what the store procedures were doing is some of these third party payloads that we're getting for the data, they're humongous, right? So they're flattening it out, they're doing scan queries, and it was just super slow and super inefficient. Um, and there was no modularity. So it was really hard to test. We were having a lot of problems where the same old problem that all of you've heard before, training doesn't look like prod. Our process was basically data scientists trained a model and then they told the devs, hey, we need these features available at request time. They put a fast API endpoint up that called the model and the devs would get the features. There was no talk about like how to handle null values and things like that, and they would treat them different. We'd have a lot of skew there. We'd have a lot of of data contract violations, and it was a bit of a mess, right? So, so the challenges that we had is we have a high number of on-demand features. I've heard a lot of talk from a lot of the previous or a lot of from the previous talks about on-demand features, which is really refreshing to hear. Uh, Latency, it was a problem because we were doing like heavy scan queries. Now, we are approving a leasing process. Some of you are working in industries where your latency needs to be in under 10 milliseconds, things like that, maybe even faster. Um, we don't need that kind of latency, but we don't want like 5 seconds, right? Under a second is it's okay for this use case. So we had some pretty heavy queries that were running to get these features. The models were coupled to software deployments. So basically, the Fast API, the model was attached to the Fast API container, and they were all deployed together in the server. And the data parsing logic, the feature transformations, they were all deployed together. And it was really hard to manage, right? And it was kind of a microservice architecture, but it wasn't a great microservice architecture. So we weren't holding state or anything like that. So we couldn't really reuse these features and we couldn't reuse a lot of the logic. Updating was really, really hard. And then uh, management wise, we had a poor validations experience. We had schema issues, blah, blah, blah. So why did we choose Hopsworks to handle this? Well, uh, we needed the ability to handle on-demand features. We needed something that had low latency, and I had worked at a company before that had a team in Ireland where we used Hopsworks for a few things, and we had tested it, and I knew that they could serve things fast. I wanted a Kafka plugin because I want to get rid of uh, calling these features down the road. I want those to be topics that are feeding this system and not a bunch of API calls and database scans. How to model registry, how to model serving layer. And I am a team of one. So I was hired as an MLOps engineer. I got them to change that to systems engineer because I do dev, I do platform engineering, any of my startup people, right? I came from a company where my team was about half the size of my company is now. And then Jim's book, he's plugged it, so I'll plug it. I started reading in his book, and it was really refreshing to read about these problems that I've had. And a lot of ML talks and stuff can be super theoretical, and he was really writing about problems that I've been burnt by, um, in previous situations. So, we went with Hopsworks, The new architecture, we were able to move uh, most of the logic off of Postgres except for a couple database calls. So what we're doing now is the store procedures still live in Hopsworks. There's 3 or 4 of them, but they're just serializing the JSON values. And the plan is to replace that with Kafka down the road and then just feed this in. But we were able to set this up so at request time, we could call the data, we could get it raw, and then we could parse it, and then we could create on-demand features, and then we could serve the model. And I wanted control of the deployments of the model, and I wanted to separate it from the microservice architecture, right? So we were able to use the serving layer that on Hopsworks that's an abstraction on top of Kserve and their model registry to serve these models. And it's been a really it's solved a lot of problems. You know, we have Python-centric feature management, but we had that before, but Python is correlated with runtime errors, right? I've never been a Python dev until this company. We've built most of our back-end ML stuff in other languages, but you know, we have minimal runtime errors due to like the schema management and the way that UDFs operate in Hopsworks. We have a unified schema for online and offline, which I've seen transformations. We can use the same transformations offline and on. I've seen that theme a lot in this conference. Low latency server calls, built-in prediction logs for monitoring and compliance. Hopsworks is amazing at logging all the features and the score and then backfilling those so we can use them down the road. That was one of the easiest things I've used in Hopsworks. Reusability of code and features and testable feature transformations, right? That's a big one. A couple of the other benefits that made my life easier that aren't necessarily feature store benefits, but I use Hopsworks for, is like I said, we had these microservice architecture. And when I first started the company, we had this model called Model 13, and they were like, hey, we want to retrain Model 13, and then we want to deploy it. You don't have any dev resources. We're going to retrain it. You're going to update it with this newer model, and we're going to swap it out. Well, all model endpoints had like the same router logic and fast API, and there were like 10 models attached to this microservice, and one requirement's .text. So when I went back and said, hey, we're not going to be able to update this because, you know, if I update this version of XGBoost in Model 13, we're going to possibly break previous model or other models that are hosted in the same container, right? This is already a really bad pattern. And you know, the dependencies are not isolated. The feature logic wasn't reusable. So, I mean, there's an easy fix there. I just put all the models in their own container, right? So we just created a service for each model. But the problem with that is the feature logic still isn't reusable because you're not really supposed to share state amongst microservices, right? And there's no way to isolate model updates. So if my model needed to be updated, we would have to redeploy all of the software. So on top of being able to decouple the features and manage the features in Hopsworks, one of the things we were able to do is get this kind of architecture where, you know, the service can call our online inference endpoints, and then we had our predict artifacts that actually deployed it, and then we had the models living in the model registry. Now, if I need to update the model, I can use the same artifacts. I don't have to create a new endpoint, and I can just update the model, or I can update the artifacts, right? So if these artifacts need to change, we can version them and we can update them and keep the same endpoint. And that seems really, really straightforward and simple, especially if you come from a hardcore dev background. But this was a huge lifesaver for a team of one that's in charge of platform, deploying the model, building the software that supports the model and the online features. So, yeah, that's my plug for Hopsworks.
Thanks, Art. Great plug too, and thanks for plugging the book as well. I'll make sure to get a signed copy out to at some point in the near future. I think, you know, I think we'll finish on this very upbeat note.